Hi children, welcome to my YouTube channel. This is the third video of the topic vectors. To see more educational videos, please subscribe my channel and click on the bell icon. In this topic, we are going to discuss about magnitude of a vector and a direction of a vector. Before we discuss about magnitude of a vector, let's try to understand how to find the length of a side in a right angle triangle. So simply we can apply the Pythagoras theorem where OA equals to OB squared plus AB squared for such right angle triangle to find the length of a missing side of a right angle triangle. We have already learned this concept in our small grades. Please look into this example. It's a line starting from origin. Origin means 0, 0 coordinate to a point A, xy. To find the length of OA, I will generate a right angle triangle OAB, whereas the length of OB is X and AB is Y. Using the Pythagoras theorem, as what you have learned in the previous slide, we can say OA squared is equals to OB squared plus AB squared. Therefore, you can say OA squared is equals to x squared plus y squared. Then if you want to find the length of OA, you can write that is the square root of x squared plus y squared. When we discuss about modulus of a vector, the modulus of a vector is the length of the vector from its starting point to its final point. If you consider this vector OA, it has started from O 0 0 for point A xy. Therefore, if you want to find the modulus of OA, we need to find the length starting from origin to point A xy. Usually represent the modulus of a vector OA using the notation the modulus mark. You have to familiar with this notation. Hereafter, when you get this notation, that indicates you to find the modulus or the magnitude of the certain component. Then if you want to find the length of OA or the modulus of OA, you can simply apply the rule what you have learned in the previous slide, that is modulus of OA equals to square root of x squared plus y squared. Remember children, this equation is used only if this vector start from origin. For there are another kind of vectors we already find it. For this kind of situations we can use the formula modulus of OA equals to x squared plus y squared, the whole thing square root. Hopefully you understood this concept. Now let's try to understand the concept using this first example. Here they have given a vector OA. It is given as a column matrix form 3 2. That means along x-axis it travel for 3 units and along y-axis it travel for 2 units. We need to find the modulus of OA. Simply this vector has started from origin. Therefore you can apply modulus of OA equals to x squared plus y squared. The length along x-axis 3, therefore you can work out 3 squared. Length along y-axis is 2, therefore y squared is 2 squared. If you simplify, you will receive the answer as root 13. This is the second example to verify the previous theory. Here they have given the vector OA is 4x minus y. You have to find the modulus of vector OA. Then 4x minus y, that means along x-axis it traveled for 4 units and along y-axis it has gone 1 unit down. That is what you indicate by minus y. Therefore, if we apply the formula OA equals to square root of x squared plus y squared, you can simply apply the figures. 4 squared plus y is minus 1. The number in front of y is minus 1. Therefore, you have to put minus 1 whole thing squared. So, you will get the final answer as modulus of OA is square root of 17. Suppose that we need to find the length between 2 points A to B where the coordinate of A is x1, y1 and coordinate of B is x2, y2. Then I will generate a right angle triangle APB. When you generate this right angle triangle, you can understand that length of AP would be the difference between x coordinate. Therefore, you can mark it as x2 minus x1. The length of BP is the difference between the y coordinate. Therefore, you can mark it as y2 minus y1. Then if you apply Pythagoras theorem to triangle APP, you can simply say AB squared is equals to AP squared plus BP squared. If you substitute the figures what you already get it from this figure, you can say that AB squared is equals to x2 minus x1 whole thing squared plus y2 minus y1 whole thing squared, that is similar to AB squared. Then if you want to find the length of AB, that is square root of x2 minus x1 whole thing squared plus y2 minus y1 whole thing squared. This is a general equation to find the length between 2 points. Hopefully some of you can remember, if you work out the coordinate geometry, even we use the same equation to find the length between 2 points. That is what you need to understand. But if you want to find the length from origin itself, you can use the same equation. There you have to consider x1, y1 as 0, 0. Then you will get the same answer what you have learned in previous example, that is x squared plus y squared, since x1 and y1 become 0 in that concept. Let's try to work out this example. The question is, given that OA is 3 minus 1 and OB is 2, 4. Find the length of vector AB. We can use two methods to find this answer. I will use a simple formula, the length between 2 points. That is modulus of AB is equals to square root of x2 minus x1 plus y2 minus 1. When you are selecting these figures, since you have a square for x2 minus x1 and y2 minus y1, it doesn't matter what is the way you select it as x1 y1 and x2 y2. So it is independent. You can select anything as x1 y1 and other one as x2 y2. With that, I have selected the coordinate of 3 minus 1 as x2 y2 and 2 4 as x1 y1. With that, you can substitute difference between x 3 minus 2 whole thing squared, difference of y minus 1 minus 4 whole thing squared. If you simplify, you receive the answer as square root of 26 for modulus of AB. That is the first method. The second method is, I will try to formulate a vector equation for AB. If you use the vector trigonometry using the previous video, you can understand that AB you can find by the vector combination of AO plus OB. If you are still not familiar with this, please refer with the Vectors for Beginners lesson 2, or if you still have a doubt on this concept, please put a comment on this comment box. With that, I will try to help you with different concepts. Right. Then if I obtain the expression for AB, that is AO plus OB, but the available vector component is OA, then I can say vector AO is minus vector OA, that is coming under negative vector theory. Then we can say AB is equals to minus OA plus OB, minus OA. OA is 3 minus 1 plus OB. OB is 2, 4. Then if you multiply with this negative mark for this with OA, you will obtain the answer minus 3 and plus 1 added to plus 2, 4, you can say minus 3 plus 2 is the x components, plus 1 plus 4 would be the y component. Then you will receive the column matrix format for AB is minus 1, 5. Then you can find the modulus of AB by obtaining the modulus of the vector minus 1, 5. With that you can apply modulus of AB equals to x squared plus y squared, the square root of it. Then the x value is minus 1 and y value is 5. Therefore you can work out modulus of AB equals to minus 1 whole thing squared plus 5 squared. That answer would be 26. There is one common mistake where most of the students do is they forget to put the minus bracket at the minus figures. Therefore you will obtain a wrong answer. So remember that you have to put a bracket for this when you are working out with square number of a minus value. Let's try to verify this theory from another example. In example 4, they have given vector OA is 4 2. It's given in column matrix form. That is 4x plus 2y. And OB is 3x plus y. Find the length of vector AB. Initially, I will use the method 1, that is modulus of AB is x2 minus x1 plus y2 minus y1. Therefore, you can work out x2 y2 as 3 1. That is I obtained from OB. And x1 y1 as 4 2. OB is 3 1. OA is 4 2. Therefore, if you put into the formula square root of x2 minus x1 whole thing squared plus y2 minus y1 whole thing squared, you can say 3 minus 4 whole thing squared plus 1 minus 2 whole thing squared. With that, if you simplify, you will obtain the answer as root 2. Then the second method is we will form a vector equation for AB. You can say AB is equals to AO plus OB, whereas AO but available vector is OA. 4 2 is the vector OA, but we need to find AO. So instead of AO, you can write minus OA plus OB. With that, you will obtain the column matrix form of vector AB is minus 1 minus 1. Then if you put into the formula modulus of AB is x squared plus y squared, the square root, you can obtain the same answer, root 2. So from both methods you will obtain the same answer, and you can use any method you prefer to be easy. The next important part in this topic we have to learn is the direction of a vector. When you measure the direction of a vector, we use two different ways to measure the direction of vector. First method is we measure the angle from x-axis, or certain questions it's represent as y-axis. Right? So the first method is we measure the angle from x-axis or positive x-axis, and the second method is we measure it as a bearing. When you measure a bearing figure, you have to remember that always we measure a bearing from north, the clockwise. You keep your hand up and you rotate your hand towards the clock rotates. That is called clockwise. Therefore, always you measure the angle from north clockwise. That is a concept you have to learn when you are working about direction of a vector. In this example, they have given a vector A 2, 4. Other than that, you can say 2x plus 4y. Then we need to find the direction of the vector with y-axis. And second part is we have to measure it as a bearing. Let's try to find the answer with y-axis. Y-axis means x-axis. That is the angle theta where you need to measure. Then I will perform a right angle triangle, whereas if you consider to the triangle right angle triangle and the angle theta, opposite would be the height, that is 4, the y value 4, and adjacent is 2. the length along x-axis. Therefore, you can work out tan theta is equals to opposite upon adjacent, that is 4 over 2. With that, you will obtain the angle as 63.4. So that is the answer for part A. That means if you want to find the angle with the y-axis, the answer would be 63.4. Then the next one, bearing. As a bearing, if you measure at an angle at a bearing, what you need to do is to measure the angle from north clockwise. That means according to this diagram, from y-axis the clockwise. Therefore, you can work out the bearing figure as 90 minus 63.4. How do you get that answer? We know that angle theta is 63.4 and the angle between y-axis and x-axis is 90. Then if you remove the angle 63.4 out of 90, you will obtain the bearing angle for vector A. Hopefully you understood this theory. In this example, they expect us to find the direction of the vector A, 1 minus 3 with y-axis and as a bearing. Initially, if you make this diagram for vector A, you can understand that it has traveled for 1 unit along x-axis and 3 unit towards negative from y-axis. Therefore, if you want to find the angle, that is the angle what you have to measure is the value for theta. Then if you draw a right angle triangle, you can say tan theta is equals to 3 over 1. So here, when you're working out with this angle, don't worry about this negative value. Just ignoring the negative value, you just find the figure. With that, you will obtain the answer 71.6. Then, if you mark 71.6, you can understand that if this coordinate goes from 1 to 3 even, you get the same angle 71.6. But here you need to represent it that is below x-axis. To represent that is below x-axis, we will mark it as minus 71.6. That is the answer for angle with y-axis. As a bearing, you can see that as a bearing, how to measure from y-axis to this whole way. We know that initially, if you want to find this angle, if you start from y-axis, if you travel for 90 degrees, it reach up to x-axis. Again from x-axis, you are traveling further 71.6. Therefore, the bearing value turn up into 90 plus 71.6, that is 161.6. Hopefully, you understood how to get this answer. Example 7 is to find the direction of vector A minus 3 minus 4 with y-axis and as a bearing. So, initially let's try to draw this diagram for vector A, that is along x-axis minus 3, that means towards minus x-axis it is 3, minus 4 is towards minus y-axis 4. Therefore, the vector OA is as shown in the diagram. If you want to find the angle with a positive x-axis or x-axis, initially find the angle theta. You can apply tan theta is equals to 4 over 3. As I mentioned in the previous question, just ignore the figures, ignore the sign negative. You have to find the value for tan theta as 4 over 3. With that, you will obtain the answer minus 53.1. Then we need to find the angle from positive x-axis or y-axis. That means you need to measure the entire angle from x-axis up to the value of up to the line of OA. With that, you can understand that if you subtract out of 180, you can obtain the angle from positive x-axis. Then, since this is in the negative side of the x-axis or below x-axis, we represent it as minus 126.9. So that is the answer for this angle generated with vector A with y-axis or positive x-axis. If you want to measure the angle from as a bearing, what you need to do is you have to measure the angle from y-axis clockwise up to the line of vector OA. Therefore, you can understand that if you travel from y-axis to x-axis, that is 90. Again, x-axis to minus y-axis, another 90. That is up to there it's 180. Again, if you come up to the minus x-axis, you will turn up to 270, adding another 90 to initial 180 degrees. Then if you want to find the bearing, you have to subtract the angle theta 53.1 out of 270. With that you will obtain the bearing angle as 216.9. Hopefully you have understood the concepts in this video. If you had a doubt, please don't hesitate to put this on comment section. If you like this video, put a big thumbs up.